exam will come as either grouped or ungrouped data. So you have either grouped data or ungrouped data. So let's first establish the difference between what is grouped data and what is ungrouped data. I know you have not done this topic, it's a grade 12 topic, but you are going into grade 12 next year. So you just have to familiarize yourself. And I know that in grade 9 you did part of this. So yeah, this thing wants to 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 disturb me. So you know that when you're talking of grouped data, it's like, let's say in a class you have you have test papers that you've received from your teacher, and then on those test papers you happen to have, maybe let's say 5 people who have gotten 40%. There are maybe let's say 7 people have gotten 50%, and maybe 8 people have gotten what, 100%. So what you do is that when you are trying to to tabulate or put it in a table, you'll be putting them in ranges to say, okay, let's not necessarily say like 4 people got 40%. Let's say person 1 got 40%, person 2 got 41%, person 3 got 47%, but they were all in the range of 40 to 50. So you don't want to write a lot, but you instead want to just say in the range of 40 to 50. 8 people are the ones who got this number of marks. So whenever you have this representation, this thing that's showing here, how do I even remove it? It's going one side, but once I move here, let me see. Alright, let me just try to zoom a little bit. I will not be pointing my case, but this first row that's showing amounts here, you can see that here in the first box you have a range of 0 to 100, 100 to 200, 200 to 300, 300 to 400, and so on. So these things have been put in groups. That means that here it's saying the table shows the expenditure of 90 farmers in a particular farming season. So number of farmers who let's say in this case, as the data is interpreting, the number of farmers who got or who earned money which was in the range of 0 to 100 were only 5. So 5 is the number of times they appeared, or how many farmers got that much. Are you following the point here? Yeah, so that means that even if you are looking at this 5 will be called as the frequency. Why? Because remember, when we are doing physics in waves, we are saying frequency is the number of times something can happen. Even in a simple pendulum, you know that it means basically the same thing. So in mathematics here, we mean frequency is the number of times farmers who earned an amount from 0 to 100 appeared on a list. So this type of data which is put in groups like this is what we refer to as grouped data. And grouped data will come in such a way that you will not have groups. It will be more like this, only one number like that. Then you just know that here now we are talking of what? Of ungrouped data. Now there's this that always comes. This question carries 6 marks, while you have to calculate the standard deviation. But then, since I'll just be explaining, I'll not be writing, of which I hope to get a writing part very soon, I will need you to follow up and then write down this example. I need you to write down this example and the example I'll do. After doing that, you answer the exercise that I've already posted. So for the exercise, you send it, I check. Actually, also send the examples these so that I see that you've written them in your book. So let's start with the standard deviation. What are the processes used in calculating this standard deviation? Now, there's a reason why I've mentioned grouped and ungrouped data, because grouped data calculation is different from ungrouped data calculation of standard deviation. So first thing you must identify is, am I talking about grouped or ungrouped data? In this case, you're talking of grouped data because I've told you how to check. It's put in intervals like that. So let's go on this diagram that shows us the solution. Yeah, if you look at this table here, the exact way I've written this table is the exact way you must remember it. They will not give you in an exam, but you must draw this table in order for you to calculate your standard deviation. So your table must have the amount. It will not always be necessarily amount. It can be another thing. Maybe you're talking of trees. They can talk of different other things. But all you have to know is that when you're having ranges there, what you're talking of is what is this box, which has to contain these ranges like that, or we can call it the class. Sometimes it will be class, sometimes maybe or marks obtained, whatever they can put. But as long as you see that there's arrangement like this whereby it's put in intervals, you know that this is the first box I must write. The next box you are writing is called X. Now where are you getting the X and what does the X represent? You understand what the X represents very soon, but for now just keep it as it's the X. Now, how do you find out the X for ungrouped data? So I'll only be biased towards ungrouped data. I don't want to explain anything related to ungrouped data. How do we get these values? Now, I want you to get your calculator and add 800. Let's start from the bottom here, and 700. Once you get that value, divide it by 2. What number do you get? Pardon? You are getting a 750? I'm saying add 800 plus 700 and then divide the answer by 2. Okay. So that's basically how we fill up this table. And this will be your second table always when you're calculating standard deviation of what? Grouped data. So you can fill up this table just the way I've told you to say. You just add these two values and divide the what? The answer by 2. Then you move to F, which is the frequency. How do we find out what the frequency is? Let us go back to the diagram. I told you that the frequency is the number of times something repeats itself, isn't it? So here we are looking at the number of farmers. So here 5 farmers appeared. So here mostly, or in all the papers that I've checked, at least the second box or this that shows number of something always represents the what? The frequency. So frequency is not something you calculate, but you just have to identify it. Say, okay, this box represents what? Frequency. Then once you identify it, you are able to do what? To fill up this. So you just put the values exactly the way they are supposed to be put. Though sometimes here they will not give you maybe this value, the last value there. Why? Because sometimes they'll give you the overall or total frequency. I also want you to add 5 plus 16 plus 17. Add up these values that are in the second row and give me the final result. Yes, so you can see that these 90 farmers represents what? The total frequency. So sometimes they may not necessarily give you these two at the end. Why? They want you they want to see if you can use this value on top here for the frequency to be able to find out the last value there. So what you do, you simply add up all the numbers here and then subtract them from the total frequency there. Though in this case we've already been given what we want, so it's all well and good. So you just list them like that, put them in order, and then at the end, add all the values here, and then put your answer here. You are putting the totals here because this is the process of calculating standard deviation. This GE like thing here means summation. So sum of all these things here gives us 90. That is what this symbol represents. So sum of the frequency gives us what? 90. Moving on to f of x. F of x means when you don't have a sign in between two letters, that means that there is multiplication. So here it's telling you that for you to get the values that are here, you have to multiply f times what? X. So what you do is say 2, this 2 times 750, you'll get this value, 15. Then if you multiply 7 times 650 again, you get this, and so on and so forth. After finding out these values, again you get their sum. You say, okay, now sum of f of x, because this is f of x, will give us the total of that. Are you following? Yes. So the only tricky part about this standard deviation is remembering the table. If you're able to remember the table with how it follows each other, the calculation is very easy. Next thing we have x squared. X squared, from just the x squared itself, it means get this x here and do it to the power 2 or multiply the x times 2. Not okay, not necessarily multiplying the x times 2 because x to the power 2 means different things. So it means you are multiplying 750 times 750. Or in a calculator you say 750 to the power 2. Don't say 750 times 2. 750 times 2 is different from 750 to the power 2. Then after squaring these, you'll be getting the values that are here. From there again, find the sum and put it here. Though the sum for this one is not really necessary, and so they didn't put it here. But you can also get the sum and put it here and say the sum of x squared will give us what? The total of this. Finally, we have f of x squared. So here you have f here, you have f, then you have x squared. So remember the x squared is this one. So it means you're multiplying the x squared times f again. That basically means that if you go here, let's use this table because if I go up, that thing will come. So if you are getting this value, which is x squared, you are going to multiply it by what? By 2, and then get this value that is here, because they are saying get f and multiply it by x squared. So get f multiplied by x squared for you to get these values, and then from there find the sum. Now, it's very important when you're performing calculation of standard deviation to be precise. So you must not rush. Once you miss a certain value, it means everything you'll be calculating from there will be what? Wrong. After filling up this table, it's the first part of solving the standard deviation. And standard deviation is very easy, even if they give it 6 marks. The next thing you do after finishing this table is to what? Calculate the mean. Mean is represented by x bar. Getting x and putting a line on top, this is what we call as x bar. So this formula for mean is always there in the exam. I will show you once I'm done with this presentation where you can find out this, where these formulas are. So this formula for mean is the first that you introduce to get the mean alone. So mean is equal to summation of f of x bar, summation of f of x bar If I even put f of x bar here, should be this one. Should be summation of f of x, not summation of f of x bar. There was an error then here. Over summation of f, which is this. So what you simply do is get the summation of the f of x, which is this one, put it there. Summation of f, get it, put it there. Divide the two to get your what? Your mean. The mean will be used to find the standard deviation, because this formula here is what we use to calculate the standard deviation. So the standard deviation is equal to the square root of the sum of f of x squared. Remember, f of x squared is this, so we're getting the sum, which is this. That's why you can see the value here, which is appearing there. It does not mean that you're squaring this value now. Remember, the f of x, the sum of f of x squared is what is here. So you're just more like substituting this with the total there over the sum of f of x, sum of f, which is sum of frequency, which is 90 there. Put it there as well. Then here you have to be careful because this minus is outside and the value you are putting here is inside the bracket. So you cannot subtract this minus this. No, there's no such mathematics. Or you cannot start subtracting without squaring first. So you square things in the brackets. Don't include the negative. The negative stands alone. So you square this. You do this to the power 2. After getting that value, make sure that this you divide first before subtracting any value that you get there. Don't subtract things on the top but minus this. No. Divide first there. And once you get that value, the square of this now, subtract them, get the square root, and finally, that is your standard deviation. Is it hard? Yeah, so that's how we calculate standard deviation for grouped data. Now I need you to be practicing these things because in as much as it can look simple, it's very, very forgettable. I'll show you these formulas at the end of the presentation. There's no need of mastering them. What needs to be mastered is how to write this step, what you have to put, amount, x, f of x, f. These things and the format must just be remembered no matter what. Okay, so you have done the first part, which is calculating the standard deviation. Now, you are using now your graph paper. Answer part of this question on a sheet of graph paper. Using the table above, copy and complete the cumulative frequency table below. So there is what we call relative cumulative frequency table, which will have points, which will end by 1 there. Then we have this is just a frequency table. This one is not hard to fill in compared to the one which has got points. So this one, what you simply do, whenever you see that on a part where they have asked you to complete, or you are looking at a cumulative frequency and not a relative cumulative frequency table, it's very easy for you to fill up. But when they ask you relative cumulative frequency, it will be a different situation. So in this case, what we are simply doing is, you can see here there is 0. So you get this 0 plus 5. You would get a 5 there. 5 plus 16, you get a 21 there. 21 plus 17, you get a 38. 38 plus 17, you get a 55. 55 plus 14, you get a 69. Then 69 plus 12, you get a value here. A value here times 7, you get a value there. A value there times 2, you get a value there. And that's basically how we fill it up. You get your 1 mark. So going on the graph here, they didn't show it. Even here they didn't show it. But that's basically how you fill up this step. Why is it necessary to fill up this step? Because it's the one which we are going to use to plot our graph. So I'm giving you like 1 minute. I want you to draw up this table, finish up these values, and tell me the values you finish up with. The first part, yeah, Roman numeral 1. Then we look at the graphing, and then you can look at the last question and finish up the class. Not done yet. Alright. So what values have you gotten? Perfect. So you can see that the final result you are also getting what the the total frequency, which is 90 farmers, which shows that what you are doing is correct. Now let's look at this part where you are plotting a graph. Have you ever plotted a graph before? Okay. So we'll go here. First thing is let's look at scale. Scale is very important in mathematics when you're plotting. If you cannot understand the scale, then you're not doing anything, then you've drawn wrong things, you'll not get any marks. So we'll first use this instruction which says use a scale of 2 centimeters to represent 100 units. So here, when you go on your graph here, you get your ruler and measure 2 centimeters. But if you are someone who uses a graph frequently, you know that the distance from here to there is what is a 2 centimeters. But if you're not sure, you always measure to say, okay, 2 centimeters is which distance. Now we have measurement in the horizontal and in the vertical. This is the horizontal, this is the vertical. Going up like that and going like this is the what? The horizontal. Now, apart from that, there are some rules that are important when you're plotting a what? A graph. The first rule is putting the title of the graph itself. So this graph is saying draw a smooth cumulative frequency curve. So the name of this graph here on top here, which they haven't done, is for you to write a graph, the cumulative frequency curve there. Apart from that, here around the corner here, you have to make a a section of where you're going to put your what? Your table. This table that you filled up. Why are you putting this table? It's the one we are using to do what? To plot. So it has to what? To appear on the graph paper, but it does not have to be that big such that it has to eat up a lot of space. It just has to be something that you must put maybe at a corner like that. Maybe from here to there, and then you put it. Another rule is putting the scale they've given you. This scale that they've told you, you put it there and say, okay, after or before drawing up, you say 2 centimeters to represent 100 units on the horizontal axis and 2 centimeters to represent 100 units maybe on the vertical axis. If they've said, what's this? If that's the scale they've given you. It's very important to put those things I've told you, even in physics and mathematics. Next thing is plotting the graph. First thing is using the scale. So if we go back here, we're told 2 centimeter box represent 100 units on the horizontal axis. That means that for every box we'll be moving 100. So for every 2 centimeter box we are moving 100. But remember, at every starting point you start from, it always has to be a 0. So this is 0 here. So from 0 to another box, they are saying for every 2 centimeter box, that will be counted as 100. So we'll be moving in 100, 200, 300, 400, 500, 600, 700, 800, maybe even 900. Mm, sometimes you may be told 2 centimeters represent 10 units. It means for every 2 centimeter box, you'll be counting as 10. So this will be 10, 20, 30, 40, 50, 60, and so on. It depends on what they've told you. So remember, this is for the x-axis. And for the x-axis, when you check here, you can see that for the x-axis is always on top. This is the x-axis, this is a y-axis. Or another way of remembering is, okay, I won't tell you this way because sometimes they might change, but all you have to know is that the one on top is x and the one down is y. So the one on top, since it is x, it is the one which is the horizontal axis, and that's why we've used this scale in order to draw up this what? It's a graph. And 2 centimeters represent 10 units on the vertical axis. So vertically here we'll be moving 2 boxes, but they'll be representing what? 10 units. So you have 10, 20, 30, 40, 50, 60, 70, 80, 90, maybe even up to 100. How far? Do you want to draw up this first before I continue the graph so that I show you? Pardon? Alright, perfect. Now, we start with the issue of protein. So, we'll come here. The first points are 0, 0. So, this is the first point here. You put a dot. You have to be precise and handle with accuracy these things when you're doing them. And also cleanliness. No, no. You, So, like I was saying, so you move to the other point, which is 100, 5. So you come on 100 on the x-axis here, and then move to where 5 is. Remember, if this is 10, then it means the middle of the box here is 5. You have to learn how to count even these small boxes. If you move from 100 here and then you are counting these two small boxes here, if this has to be 10, and then you are counting them as 1, 2, 3, 4, 5, are you sure they are going to reach 10? If they can reach 10, then you are counting well. But let's say this here is 5. It means when you're counting, you'll be using for every 2 boxes, that will be 1. So like 1 for 2 boxes, 2 another 2 boxes, until you can reach your 5. But in this case, our 5 is this point here. So they are saying 100, 5. Don't know, these people did not handle this thing with accuracy, because it was supposed to be 100 there, and then 5 is somewhere here and not here where they put it. So they were wrong. So next point has to be there. Then we have 200, 21. So 200 is there. Then this is 20. So if this is 20 and this is 30, it means in between here, this is the 25. So if this is 25, you have 24, 23, 22, 21. Actually, it has to be somewhere here. So you have to count in such a way that you are precise with everything you are doing. After finding your 21, you put a point again. Then you do the same up to when you are done putting the points. And then in these statistics, you never use a ruler to connect your points. It's a smooth cumulative frequency curve. And so you must connect with your what? Your pencil like that. Please, you are not drawing. So your pencil must be sharp, or must be sharpened, and things must look clean. If possible, just draw it one time so that it looks good. We're done with plotting. So that's basically how you plot. Showing your method clearly, use your graph to estimate the interquartile range. Use the word quarter in order to understand this. What does a quarter mean? No idea. 1 over 4. Good. So a quarter means 1 over 4. And so there are 2 types of quartiles. So sometimes they can just say find the interquartile range, but sometimes they can ask you find the upper quartile, lower quartile, and semi-interquartile range. So I need you to note those down. You can be asked to find the interquartile range, as in this question. You can be asked to find the lower quartile. You can be asked to find the upper quartile. And then you can be asked to find the semi-interquartile range. You've written down, eh? Alright, perfect. Now, for this question that is asking interquartile range, it means for you to find the interquartile range, you need your upper quartile and lower quartile. Upper quartile, since the quarter is out of 4, that 1/4 is called a lower quartile, while the 3/5 is called the upper quartile. That's something that you must just master. So when you are finding the upper quartile, you say 3/4 times the highest value. Here, when we come back here, the highest value you found of this frequency was 90. And note that you get the number from the y-axis and not the x-axis. So you say 3/4 times 90 and get your 67.5. That's your upper quartile. So you come where there is 67.5 here and align with your graph neatly with a ruler. Where it intersects with the x-axis, you go and check the value there. The value it will give you, so this is somewhere 490, is what you call the upper quartile. You don't get the value from here, even if it's the one you use to calculate the first calculation. So first thing, you say 3/4 times 90, the highest value here on the y-axis, then get our value here. Then align it with the graph to get the one from the x-axis like that. Well, for you to get the lower quartile Q1, you say 1/4 times the total again. But after getting that again, you align it with your graph and then get the value that is here, which is approximately 280. So if the question only asks you to find the upper quartile, you do this. If the question only asks you to find the lower quartile, you do this. But if the question asks you for the interquartile range, you need the upper quartile and the lower quartile, and then you subtract them, and then you get your interquartile range. So when you subtract these two, you now get your interquartile range. Then if the question had asked you to find the semi-interquartile range, the procedure would be the same like this, but since it has mentioned semi, it means half. So after getting your overall answer here, simply divide it by 2. I hope on the interquartile range everything is clear. Perfect. So this is question 2, but we're not going to do it. Instead, I'll put it as part of your work. Part of your work, yes. Now, I think I'm done for this one. So you need to do this one. But what I haven't talked about is the percentiles. I'll talk about them when I'm looking at ungrouped data. But one more thing I wanted to show you is how you fill in for a relative cumulative frequency table, not for a frequency table. So let me just do this.